based on this Daniell cell reactions of zinc plus copper 2 plus to zinc 2 plus and copper, the oxidation and reduction reaction in the electrochemical cell. So we have described the delta GR, or the change of free energy of this reaction, to be a function of the difference between the electric potential of zinc and copper and the RT ln of activity zinc 2 plus and activity of copper 2 plus. So this means that the energy that you can take by allowing this reaction to proceed to the right, by the free energy that you can take, or that you will get, is a function of electric potential between zinc 2 plus and copper 2 plus, and the ratio of their ions activities, right? So if you want to, if you're interested in doing a reaction, so normally you want to maximize the energy that you can get from that reaction, right? So you can maximize this, of course, by you want to make this value bigger, right? Or for spontaneous reaction, it has to be more negative. Okay, so we describe delta GR, and we describe the delta GR naught of that reaction, which is 2, which is coming from the number of electrons participating in the reaction, times the Faraday constant, times the difference in the electric potential of zinc 2 plus and copper 2 plus, right? So okay, so let's look at the case when this reaction has reached equilibrium, right? So when this reaction has reached equilibrium, so it means that you have reached delta GR0, which means there's no more free energy that you can take from this reaction, because it has reached equilibrium, right? So delta GR0, we have the description of delta GR from the previous paper, where delta GR is equal to this term. So right, so this means that 0 would be equal to this term. Okay, just write that down again. Yeah. So to delta GR naught, right, plus RT ln activity of zinc 2 plus and copper 2 plus. Okay, so this is 0, and we know that delta GR naught is equal to 2F times the electric potential difference between zinc and electric potential difference with copper, right? Awesome. All right, so what now? Okay, right. So as this is at equilibrium, right, so every reaction has an equilibrium constant, right? So this equilibrium constant sort of like dictates when the reaction stops, right? So the reaction stops when you have reached equilibrium. Where is that? That is where you have reached K. That's where you have reached K, right? K of the reaction, equilibrium constant of the reaction. So what is the reaction? This is the reaction. So how do you express the equilibrium constant? It's the activity of zinc 2 plus times the activity of copper metal over the activity of copper 2 plus times the activity of zinc. Now, because this is pure metal, we can we assume that the activity is 1 of copper metal, activity of zinc metal is 1. So you have only, now you end up with only the activity of zinc 2 plus and copper 2 plus. Right. So this is K, and this is this expression. So this looks familiar, right? This looks familiar. It actually looks the same. So at equilibrium, the system will reach K values, right? So this term here is actually K, right? So you have reached K. So at equilibrium, delta GR equals to 0. So I can write this delta GR naught is equal to minus RT ln activity of zinc 2 plus and copper 2 plus, or minus RT ln K, right? Minus RT ln K. Okay. Right. Delta GR naught. Alright, so we have the expression of delta GR naught from this, or this one, same, and delta GR naught from the difference in electric potential. So let's combine that together, right? So what does this mean? This means that you have reached equilibrium, right? Because the energy, the free energy that is generated to be the driving force for electrons, right? This is the free energy generated. The free energy generated by having a difference in electric potential, right? If you have electric potential, it means that you have a driving force for the electrons to move. That's energy for you to do work. Now here it says that at equilibrium, right? At equilibrium, that energy is being compensated. By K, meaning that this energy is compensated, meaning that the energy is working in the opposite direction, due to the fact that activity of zinc 2 plus over copper 2 plus has reached a certain value, which is the equilibrium constant value, that works against the free energy of the electric potential difference. All right.